All right. All right. So here we go. That's how I start every video. Okay. Input, say it. Why are we graphing again, as someone said as they walked in? It's because input output takes care of everything in life mathematically. All right. So what is f of x? Is that input or output? What is that notation for? It's actually notation for output. And I want the x's that create those outputs. And we already done this. All right. But I do have to hit this one and then all of these. I probably could do a highlighter. I don't feel like changing. So those are the outputs that are less than or equal to 0. So what are the inputs that have that happen? 1. I don't know if I should be using braces on it in the midst of a interval notation scenario. So maybe brackets. That's how I've always done one number only in an interval, even though that's not really an interval. And then I can't read those. Is that 2 and 3? And why is it brackets? Because 2 and 3 are called what? Starts with the Z. We have no time for this. Zeros. Where were you? Okay, zeros. All right, but then greater than 0, let's change the colors here. Where are the outputs greater than 0? Here, and here, and here. But what are the inputs that create that is the answer to the question. And that's negative infinity to 1, not including 1, so I have to exclude it. 1 to 2, not including 2, and then 3 to infinity. All right, and then that's a much different thing there. So we can use highlighters or use a pen to denote those colors, input, output. All right, I gotta hide this though, doink, because I don't want to accidentally hit that. Okay, and then use a number line, and then we've done this before. Ooh, okay, thank the maker. This does look factorable. We already did this kind of question. Okay, so that's why I'm gonna, as a note person, just do it. You know that this is 9x. The only way this would work is if the parentheses I have left over are equal. Squared, I wasn't done yet. All right, then x plus 2. And then pull out a negative 4, and then you do get x plus 2. So I could see that in the future that these parentheses would be equal, so therefore grouping does work. To reference our previous chapter, where is your ID? I told you to put it on before you walked in here. Okay? Everyone's got to do it, so let's all do it. I have to tell you almost every single day. Anyway, those are the things I enjoy in teaching. Constantly and totally repeating myself over and over and over and over and over. Is this annoying? Saying over and over and over again? That's how annoying it is to have to repeat myself over and over and over and over and over again. Okay? You can be mad about it. You know what the best thing to do? Stop doing it. That'd be the best thing. That would be the one that makes sense. Okay, now you want to graph these as x-intercepts. Okay, so here is the y-axis. And then here is negative 2. That is one of the zeros. Oh no, then the other ones are fractions. Negative 2/3 and positive 2/3, which are just less than 1 and not less than, and a little greater than negative 1, whatever. Okay, and then our whole idea of this graphing like this. Doink, doink, doink. Okay, because of the polynomial dance, I can make that sketch and then I don't have to do a number. I think that says a number line test. I never did that. Input, say it. Output. This tells me if I plug in these x values, I get a positive. This tells me if I plug in any of these x values, I get a negative. This would be a negative output value, and this would be a positive output. That's a number line test. It's already done with input output, knowing what the graph looks like. That's why I don't care about the number line test. I care about the picture. And who do I want? Above or below? Which one? Below. So it's these, this, and this. Right? So negative infinity to negative 2. Now, is it a bracket or parenthesis? It's a bracket because these are zeros. and then union that with those, sorry, I went over that pretty fast, but 2/3 and negative 2/3 are those other zeros. So this has already been tested. You've already been tested on this. Okay? All right. So now how does that translate to rational functions? The exact same way. Input, say it. Output. So if I'm, we'll break this all down. This is all slow enough. For what values is g of x equal to 0? Anyone? X, anyone? Intercept. So actually, for what value of x? 0 for x, because 0 comma 0 is my only x-intercept that I see there. Okay, we do have to keep track of these, and then I'll tell you why we need these. These are very important. It's the only little stretch of your brain that makes us slightly different than this analysis that we already know how to do. Or you're severely and totally, anyone? Behind. So x equals -1 and x equals 1. That's where those asymptotes are. But notice that the asymptotes, before and after, there's like changes in the graph from above or below to above. So we got to keep track of that and think about things when we're solving an inequality, which is what we're getting to. So what we're getting to is these are the critical values here. These are where the graph switches from above to below or below to above. Sometimes on asymptotes, we could have an asymptote here and a graph could be like this. And we just got to be aware of that. Sometimes that can occur, right? We've seen that before. Okay, whatever. These are all things that we're supposed to know. But usually there's a flip-flop. And that's how you figure out where the graph is negative. Okay, so where is g of x negative? Well, that is above or below, everyone. Below. So maybe I'll grab the highlighter now and highlight that where are the y's negative. Well, I want the x's though. So the x's that make that happen to make it negative are not at -1. -1 is undefined. When I plug that into the equation is undefined. That's why we're getting a vertical asymptote. All the way up to 0. 0 is a 0. It doesn't make a negative output. So you can't include 0 as you can't have a bracket there. That's what I'm blabbering about there. So that's the 0. And then union that with 1. Oh, okay, to infinity, because this graph will never get to 0, ever. So obviously there's a horizontal asymptote too. And we should be aware of that too. We should be aware that there's a horizontal boundary that's limiting what the graph is doing there. These are the notes. This is how you analyze, but we're going to have to review graphing, of course. And then this is a different question. Where is g of x greater than or equal to 0? Well, that's definitely apparently Chewbacca's in this class. And then from here, is someone okay over there? And this, right? 0 is a 0, right? So when I plug in 0, I get 0 as an output, and that solves the scenario. So this goes from negative infinity to -1. What do I put on -1 because it's equal to? A bracket or parenthesis? I tricked you. Why is it always a parenthesis no matter what? I worded that on purpose that way. An asymptote can never be a solution because the asymptote is where the graph is undefined. -1 creates undefined for the output that it is not an output. Okay, so it cannot be a solution. Union that with, what do I put on 0 then after all that? That's a bracket. I tricked you again. Why? What happens when I plug in 0? What's the output? 0. Is 0 greater than or equal to 0? True or false? True. So the point I'm trying to make is never do asymptotes have a bracket, but you better be careful on zeros. Zeros can. All right. And then comma 1. What do I put on 1? A bracket or parenthesis? I heard someone still say bracket. I'm going to hit my head up against a wall. Okay. It's an asymptote. It can never be a bracket. I literally just said that. Someone said bracket. All right. Got it? All right. Do I have to do this with this one? Yes. Fine. Fine. What I'm going to do though, forget about a number line thing. Is that what you have here? Is that right? No. What? 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 I did something majorly bad on this. No! Did I screw up?
The notes in the home 30.
I did. Wait, that's the same as the. No. Okay. You're gonna. You know what? Forget this. Okay. Use this. Wait, this is yours. Okay. All right. That's your notes. Which one's the notes? Okay. Scratch all that off. We're not going to do all this. Here's what we're going to do. Here's your next. Wait. Come on. There we go. Change the 4 that you have in the notes. I know what I just had a really bad printing day today. So you see the 4 numbers on the notes with the holes? Change them to these, and then this is how we're going to do it. Don't get frustrated. I'll just skip this one. I didn't want to do it anyway, so there you go. Good. All right. So here's how we're going to do this. Oh, we already have a tough one. Boy, these other teachers, they like to start off with the hard ones. Okay. Now I just lost my pen. Where did there? Everything's okay. We're going to survive. All right. Already got a strange one here. First of all, I need to make a sketch of this. I'm not doing a number line analysis here. Where do I have a vertical asymptote? Everyone should know this. X equals what? -2. Do I have any x-intercepts? Do I have any y-intercepts? No and no. Do I have a horizontal asymptote? Apparently I'm drawing one. Why is it y equals 0? Because the numerator's degree is what? Less than the denominator. Numerator's degree is 0. Numerator. Hard for me to say. Boy, I don't have a whole lot of information. Input, say it. This is not hard. I'm not even going to talk about those other people in the other classes. They still can't throw in numbers. I just said I wasn't going to talk about it. Makes me unable to sleep at night. I'll use another finger. -3 plus 2 is, what's -3 plus 2? -1, but then squared.
1.
1 over 1 is what? 1. So I plugged in -3. This tells me everything. This tells me this is the graph. Everything. Because I don't have any x-intercepts. I don't have anything in the numerator. I have no y-intercepts either. Wait, I do have a y-intercept. What a maroon. I can plug in 0 for x. What's 0 plus 2? 2 squared.
4.
So the y-intercept is 0 comma 4th. Guess what? I know where this graph is. Didn't I just say this rarely happens? Rarely, rarely, rarely. It happens when you have squared asymptotes like that, like double. What do you call it? Multiplicity 2. That's what I was trying to say. But anyway, just a couple input outputs, and I'm good to go. So now, where is this graph greater than 0? Anyone? Everywhere except what? Except that undefined value. So the answers for x that solve this, I don't know why I'm switching colors, but let's just deal with it. Every solution except -2, that undefined. If it would have been less than 0, it would be nothing. There'd be no solution for this. All right? So a little bit of a too unique kind of equation there for the notes. All right? Let's think on our feet here and change that second one to this one. I was doing a whole, but I don't even tell you what happened when I was copying. It was all me. I was doing some stupid stuff. Okay, but anyway, and I'm not doing a number line chart. Forget that. This does the same thing if you understand input output. Okay, what's the x-intercept? What's the x-intercept? I just surrounded it. What's the x-intercept? I should have made sure, but I know this does not have a 2x plus 1 factor. All right, I do need to factor this, so it looks like x plus 3, x minus 1. Not teaching factoring here, right? Agreed? Okay, so I have -1/2 as an x-intercept. I have x equals -3 as a vertical asymptote. What's my horizontal asymptote? X equals 1. What's my horizontal asymptote yet again? 0. And I am going to check a y-intercept, which will tell me everything what's happening in the middle. Then I just have to do a couple more input outputs. Okay, y-intercept, I plug in 0 for x. That covers up all the x's. And then I'm left with 1 over negative 3. Do you agree? Right? 0 comma negative a third. All right. So when I find x-intercepts, I plug in 0 for these. That's what's left over. That's for the movie people. The movie people. Your brain has to be able to figure that out. Okay, so I know exactly what's happening in the middle. There are no more x-intercepts except for this one through this y-intercept, and then there's not another x-intercept, so this has to approach from that way on both of these ends. Just by having an x-intercept and a y-intercept, I know what's happening in the middle. And yet again, a horizontal asymptote can be crossed in the middle. A horizontal asymptote is what happens at the ends, the controlling of the ends, nothing about the middle. All right, so this is an occurrence that can happen. Whatever. Just feel like my English wasn't great on that. And then input say it. I'm going to plug in -4 right quick, and I'm going to plug in 2 right quick just to see if I'm above or below. All right, let's start with 2 because that seems easier. 2 times 2 is 4. 4 plus 1 is 5. 2 squared is 4. 2 times 2 is 4. That's 8 minus 3, which is 5. So when I plugged in 2, don't even get the answer. Is it positive or negative? Is it positive or negative as an output? Positive. So that means I'm right. By the way, it was 2 comma 1, right? Wasn't that 5 over 5, 1? Okay, so again, these are the things that hurt my brain when students say they can't do what I just did there. Drives me crazy. All right? Nuts. There is no excuse for it. -4 times 2 is -8. -8 plus 1 is negative. All you have to say is negative. You don't even have to write -7. A negative up on top. And then what's a negative squared? What's -4 squared? Okay, fine. I'll do this one. 16. Then -8 minus 3. What do we have on the bottom? Positive or negative? So what's negative over positive? Negative. This tells me everything. I am down here. Okay, so just a little bit of evaluation. It ain't no thing. I think I am having chicken wings today for dinner. Maybe not. Maybe I'm just gonna have grill some chicken. Better for you. Okay, so anyway, I didn't finish this graph up here. Doink doink. Okay, is everyone okay with graphing? We expect this is like a review of the chapter, actually. Is everyone? Some people look sad. Are you okay? Okay, all right. All right, so where am I looking for? Above or below? Above or below? Below. Okay, so below. All right. So it's negative infinity 2. And you know what? There is no equal to sign, so we're safe with all parentheses. Hopefully you at least got that. And then it's the x-intercept to the asymptote. Yep, -1/2 to 1. Easy? I really hope so. That's because you memorize. You're good with that. We might have a hole here, so this could be a problem. Sorry, I give you a minute to write because I screwed up the printing. New one? I didn't even notice that. You guys had to tell me that I screwed up on the printing, so they have to write the new examples. I accidentally put the homework twice on the back page. Looks like I have a case of the Mondays. Anyone ever see Office Space? The movie Office Space? Nobody? I think that's mandatory watching for everyone if you're going to work in an office at some point. Oh, darn it. I thought there was going to be a hole. There isn't, is there? Right? None of those are the same. Darn. Okay. Got to be careful with holes. Holes are also undefined values, so it break up the solution system. I'll see if we get one at the end there. Bless you, whoever sneezed away over there. Hey, what's the horizontal asymptote, by the way, everyone? What's the horizontal? I should be able to actually have you do this. So make a quick sketch and then walk around. But you know what? Let's do again. Don't you like the days where I leave you alone to work, right? Okay. So y equals 1 because it's 1x squared over 1x squared. Okay. And I can't do the y's anymore. You're severely and totally anyone behind if you still don't know this. This is what I like. Half my ABers still can't memorize the horizontal asymptote rules. Drives me crazy. I said I wasn't going to go there. 1, 2, 3. We're all turning over a new leaf in that class. All right. And then it's x equals 3 twice. Here's what you can expect. You can expect a kind of weird situation going on with this. Maybe a graph on the same side, or above, or below. But we'll get the input outputs here to understand it. Oh, I forgot to do this. I'm not highlighting, but maybe I'll change colors. That is -5, 1, 2, 3, 4, 5, comma 0. And then this is, well, that's weird. 2 comma 0. That's strange. I have a feeling something different is going to happen there now. Wow. I think I know what's going to occur. I got it. We might have to do an input output here, but here's my thing. I almost want to go up here, but then it's bad for this. Could it cross this way? I mean, it could, because then that would come down here, but then what's wrong with this? This is supposed to do what? What is it supposed to do? It's supposed to behave to the horizontal asymptote. To get to that horizontal asymptote, there'd be another, anyone? There'd be another x-intercept. So I disagree that it could possibly be that way. It would have to be like this, because then it could cross and then hit and then approach this from that way. We could input output. We could plug in 0. Oh, I was supposed to get that anyway. What is the y-intercept? 0 comma, say that fraction, everybody. -10 ninths. So it is below. So that does complete the picture. And then you know what? When you have a squared asymptote, this usually does happen, but I already know this happened. Are there any x-intercepts over here? Yes or no? Are there any x-intercepts? No. So therefore the graph should be up here. I could input output to prove that. 1, 2, 3, right? That's at 1, 2, 3. So I could plug in 4. And all I would have to assess is, do I have a positive over a positive? 4 squared plus 3 times 4 minus 10, that's positive. 4 squared, 16. Oh, this is close. 4 times 6 is 24. Negative, that's -8, plus 9 is positive. All right? So therefore, it is a positive over a positive. You heard that, right? Okay, so I did get a positive output when I did that. I think it was a bigger number than that one, but at least I have a sketch of above or below. Okay, so this is unique right here, that one. But it really does hold that it hits all the intercepts and is controlled by the asymptotes. So it's all good. Now I can answer this question. Where am I looking for? Above or below? Above or below? Above. Above, above, above. And it is also equal to. So I got to be careful. So that means from negative infinity to this x-intercept, which is, sorry, -5. And what do I put on that? A bracket or parenthesis? Brackets. And then what do I put on 2? A bracket or parenthesis? Bracket or parenthesis? Bracket. 2, 3. What do I put on 3? Parenthesis. And then union that 3 to infinity, parenthesis again, because those are asymptotes. So asymptotes can never be part of the solution set because they're undefined. That's how they were created. So the graph is undefined. Ain't no thing. Chicken wing. Okay, and then you feel free to do the last one on your own. Talk with your friends. I'm going to freeze the screen. I can't freeze the video. Thanks, video. All right. Wish you had that feature. Pause would be nice. Okay, 5. I can't factor right now. What? 5? I just embarrassed myself. Good thing you weren't watching. Looks like I have a case of the Mondays. 2. It's frozen up there, right? Good. Feel free to talk with your friends. Math friends. The best friends that you can ever have. Are there any holes? Any holes, anyone? Yeah, bummer. Wow, a lot of stuff going on this one. Oh, no. What a jerky question. I think we might have to go to our calculator on this. Isn't there two really close asymptotes? So it's kind of be kind of hard to find out if it's above or below. We could input, say it. I might do it. I might drag us through it. I know use guys on the video here. You're watching me go here. This is what I was talking about. There's got to be a graph in between these two, and I got to answer this. So is it above or is it below? I got to check 3.5 negative. Oh my gosh. But that might be a calculator-ish kind of thing. That seems kind of stupid to not be. Another tough one. Another honors question. Okay, and then we do have a y-intercept of 636, which is 1/6, very small. I do have a horizontal asymptote of y equals 0. And then I do have an x-intercept at 3/5. Okay, so this tells me this has to be occurring. Oh, what a goofy graph. All right, what a goofy picture. Huh? I know. I'm talking to the internet right now. I at least know my middle part, and you should have at least done that. So let me show you where you should have got. Are you guys done with at least some of it? Yeah. Okay. You have 3 asymptotes, right? Okay. And then that middle part's got to be that. Did you at least draw that middle part? Because you should have. All right, and then there's a y-intercept and an x-intercept, and we have those vertical asymptotes in between. Now I could have done the one on the far right. What I really don't want to do though is I do have my calculator ready. I could evaluating would be kind of fun. Well, you know what? Forget that. -3.5. Here's how you do this without a calculator. So -3.5 times 5 minus 3 times 2. What kind of output would I get? So what I'm doing is I'm checking -3.5. What do I get? A positive or a negative? What kind of number do I get when I plug in -3.5 up here? What do I get? Negative, right? You get negative times 5 minus 3 times 2. So I get a negative output up there, right? Right. Okay. And then when I plug in -3.5 here, what kind of number do I get in this parenthesis? Okay. And this might be good to go through. What kind of number do I get in this? Guys are killing me. Is it positive or negative? Negative. Okay. One person knows. I don't know. And then -3.5 plus 3. What kind of number is that? That's not right. What's -3.5 plus 3? Negative. And then what's -3.5 plus 4 though? So what's a negative times a positive? This is what would happen when I plug in. So what's a negative over a positive? Negative. So that's a number line check. I guarantee you're going to have some sort of graph that looks like that then. There is no x-intercept in this little area. All I needed to know was what kind of output do I get? Therefore, that's where that graph is. Is the bell about to ring? Oh, you're making me nervous. Okay. All right. You're looking at the clock and shuffling your papers. All right. I thought it was over. And then 4, we could do the same thing. I think 4 gives me all positives on the bottom and positive on the top. So I get this. So 4 times 5 minus 3 times 2 is positive. When I plug in 4 there, I get a positive, and a positive. See how this works? Okay, so that's how I can find out what my graph is doing. And then over here, this is -5. What happens when I plug in -5 up here? I get what kind of number? Come on, if I plug in -3.5, I get this guy. When I plug in -5, what kind of number? No, it's negative. Okay, -5 times 5 minus 3 times 2. Oh. All right. And then what happens when I plug in -5 here? What kind of number do I get? -5 minus 3 is what? Negative. -5 plus 3 is what? See, and then -5 plus 4 is what? What's a negative times a negative times a negative? Well, what's a negative over a negative? So by golly, that's where this graph is. Woo! All All right, so what did we just do there? We didn't actually evaluate. We assessed what kind of number I would have gotten. And I just need to know if I'm above or below. So if I went to the graph of this, this is what I would see. I bet you would not see this though. You'd probably have to really move your window. And then after the video, I'm probably maybe at the end of the video, if anyone cares, I'll show this graph. This is the last one, right? All right. We know what less than is. You know how to answer this after this. I'm going to go to the calculator. So it's this and it's this, right? After all that, those are the only two parts, correct? Yep. All right. Do your homework. Okay, but I am going to go ahead and graph this and verify that I'm right. What if I'm wrong? Oh, how embarrassing that would be. Okay, so y equals, let me move my head here. Why do I have to be here? Yeah. Okay, clear. I'll do fractions. I almost forgot how to do fractions. That's right. All right, and then I'm going up to the board. Oh, you guys can't see this. 10 x minus 6. I'm just curious to see the graph and make sure I did this right. X caret cubed 4x squared minus 9x minus 36. We can leave y2 equals 0. Zoom standard 6. Did I miss something? I had to miss something. Let me see if I typed this in correctly. Maybe I don't want this on the video. I did. What a maroon. Okay, get over here. Go down here. Down. What is happening? Down. There we go. There it is. Second insert plus. Okay, now graph. Oh, thanks, Amanda. All right, there we go. Okay, so it is what I put here, but there's that part here. Where's that part? And I bet you it's way down here. So I'm going to go ahead and change my menu. I'm going to get that window Y minimum to be like 100. Wrong. That's the Y max. So that means 10. Y minimum negative 100. Let's see if I can catch that part of the graph. Hey-o! See that, everyone? Hey, look over here. There's that little thing I told you about. See it? You see it? Okay, good. So that was right. Okay, so we have that above, then this little U, and then that thing in the middle, and then above on the right side. Okay? All right. So maybe not quite 50 window. Let's go, or negative 100. Maybe negative 25, just to see a better version of this. Ah! This is stunning video. Not far enough. Oh, what a failure. Negative 40, maybe. I just wanted to see the graph a little bit less scaled. There it is. All right, so all the parts that I said had happened right there. Boom. Nice. Okay. All right.